Hello, my name is Jason Silverman, Product Manager of the Hydeck Electronic Division. Today we will be talking about the PDT or Project Definition Tool. Main points of the PDT are to generate documentation automatically as well as generate code automatically. We will start off in the Project Administration section over here in the project tree on the left-hand side. In this section, you can enter basic project information, including the name, description of your project, the safety approach, as well as author information. The purpose of this is for all of this to show up in the documentation, which I will show you a little bit later on. Next, the vehicle identification section, you can enter basic information about your vehicle, including a vehicle picture, which again will show up in the project documentation. The next section we can talk about is the CAN database, where you can specify your CAN messages. Once you specify a CAN message, you jump into the details and you create all the signals for your CAN message. Specify the cycle time, the type of message it is, and again, the code will be automatically generated for you just by this simple configuration. Next, we can talk about the databases. There are various databases available depending on your needs. There is an option database, which we are showing here. There are different options available depending on machine variations, which are selectable in the service tool. There is also common parameters, calibration values, and shutdown values. Shutdown values will automatically save to the EEPROM upon the K15 pin going low. State variables, of course, are used for RAM purposes and are not saved to non-volatile memory. There are various signal functions available. All you have to do is simply check the box and it will be available for use in your C code. The definition of the signal functionalities as well as the ProBlocks, which I'm about to show you, are available in the help file in the standard toolbox. The ProBlock is an example of a block to control PWM control for an output pin. In here, you would simply assign a pin from a drop-down menu, set your coil resistance, and set your PID control. There is automatic current control based on current feedback on the same pin for this controller. Automatic error handling is built in, for example, open circuit, short circuit to power, short circuit to ground. In here, you specify an error number, which is an SPN number, and an FMI number for the category, the type of category, and how it is stored. You're only showing active errors, historical errors, or both. You can also set conditions, which is a condition in order for the error to become active, for example, ignition on. You can set a release condition, which will in turn latch in the alarm, and a restricted mode, which is an inherent result of the error becoming active. Next is an example of the in-volt block or a voltage input. Here you have your raw voltage inputs scaled to your output of the block for use in your code. The standard toolbox will give you all the help you need for your particular project. For example, in this project, we are using a TTC32 controller. The help file will explain how the blocks and signal elements work. Next is an overview of all of the I/O in your system that you have configured, including system pins. And finally, we will return back to the documentation management. As said previously, the documentation will be automatically generated based on the configuration you have specified in your PDT. When I click CAN specification, for example, the document is now being generated. And here is the document that is automatically generated by the PDT per your CAN specifications. TSC1 message we showed previously will show up here in the documentation. The failure mode spec is another example for all of your error handlings that are configured in your application. This concludes this segment of the PDT demonstration. Next, I will be talking about the MST, or the Machine Service Tool.